Hi students, this is Suchadata teaching economics to class 11 and here I am with the 7th chapter of statistics and the name of the chapter is correlation. That is to say the relationship between different variables is correlation. Previously in this particular class we've been studying about one variable. But now in this chapter we are going to study about the correlation of two or more statistical series, which means in nutshell that correlation means the degree of relationship between two or more variables. And this we are going to study in detail in this particular chapter. But before that, we must know what are the different kinds of variables which are there. The first of its kind is the positive correlation. The positive correlation is when the relation is such, the correlation is such that it moves in the same direction. For example, the study of price and supply. When the price rises, the supply also rises. When the price decreases, the supply also decreases. The next relationship is the negative correlation. This negative correlation is when two variables move in different directions. For example, the study of price and demand. When the price rises, the demand dips. When the price dips, the demand rises. So, they are moving in opposite direction, that is negative correlation. Then we have the linear correlation. The linear correlation is when two or more variables move in constant proportion, that is linear correlation. You can draw a line. And non-linear correlation is when the variables do not move in constant proportion. The next is the simple correlation. The simple correlation is the correlation between two variables. As we said, the relation or the correlation between price and demand. Then we have the multiple correlation. The multiple correlation is when more than two variables, two factors affect a particular thing, that is multiple correlation. For example, if I talk about the productivity of wheat, then there are many factors which are going to affect the productivity. It is going to be the soil, the manure, the rainfall, the climate. There are many things which are going to affect the productivity of wheat. Thus, there are different kinds of correlations which could be positive, negative, linear, non-linear or simple and multiple. We are going to study in detail about these correlations and through three different methods. And now I will be starting with the first method in the next clipping. As I told you earlier, there are three methods of studying correlation in this particular chapter, and the first of its kind is called as the scattered diagram. In the scattered diagram, we actually present the graphic expression which tells us about the direction and the degree of correlationship. It is by the graphics which have been drawn that we know exactly how much and to what extent is the correlation between the variables. For example, if I have to talk about the perfect positive, then this is the perfect positive correlation. In the positive perfect correlation, we see that it starts from here and ends here. But when we talk of the perfect negative, it starts from y-axis and comes down to x-axis. This is the perfect positive correlation. This is the perfect negative correlation. But when I talk of the positive correlation, it is there are going to be equal dots on both sides. For example, if I put dots, say 1, 2, 3, 4, 5, 6, 7, 8 and 9 this side, they are going to be equal on this side too. So, this shows the positive correlation, but the negative correlation will be if there are, say, 9 factors or number of variables that I have taken 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and there are just say 6 of them on the other side. This is clearly indicative of the fact that there is a negative correlation between them. Positive is when they are running simultaneously and there is a closeness between them. But when there is no closeness and the variables are different on each side of the line, this is negative correlation. But when there are sometimes when there is no correlation at all, in the no correlation it will be this is the kind of no correlation that we have. So, when we are measuring the scattered diagram, it is merely by presenting the graphic expression and the perfect positive, perfect negative, positive negative and no correlation is what we are able to present by the scattered diagram method. This scattered diagram method has both positives and negatives. It is in fact the simplest of the method to study correlation, because by just looking at the diagram or at the graphic expression, we immediately can know whether it is a positive, negative, no correlation, what kind of relationship exists. But this is also not a very perfect method, because we cannot find out the precise extent of the correlation by this method. Thus, it just tells us about a direction, about a degree to an extent. Thus, we have to rely on this scattered diagram only to a limited extent. But for going into depth, we have to study the other two correlation methods. So, this was the first method, the scattered diagram method. In the previous clipping, we spoke about the scattered diagram method, which tells us about the direction of correlation but not the magnitude of relation. But here we are going to deal with the second method of correlation, which is called as the Karl-Pearson's coefficient correlation. And first of all, we are going to do it the way it should be, and then I explain it to you the merits and the demerits. The first of its kind, first of all, the Karl-Pearson's coefficient is written as this, that's the symbol. And now I am going to take up a sum, and which is x is equal to 2, 3, 4, 5, 6, 7 and 8, and y is 4, 7, 8, 9, 10, 14 and 18. Now, the formula that we have for Karl-Pearson's coefficient is that R, or rather Karl-Pearson, is equal to sigma xy upon sigma x square into sigma y square. So, first of all, I write the number of observation of x, which is 2, 3, 4, 5, 6, 7 and 8. So, I will find out the sigma x. Sigma x will be 2 plus 3 plus 4 plus 5 plus 6 plus 7, which gives me 35. And the number of observations are 1, 2, 3, 4, 5, 6 and 7, which means my x bar will be dividing 35 from 7, giving me 5. Now, I will draw the deviation out of it. My sigma x is 35, number of observation is 7 and the x bar is 5, which means when I take this, the deviation which I draw is 5, 2 minus 5 will give me minus 3, 3 minus 5 is minus 2, 4 minus 5 is minus 1 and 5 minus 5 is 0, 6 minus 5 is 1, 7 minus 5 is 2 and 8 minus 5 is 3. And it should always be 0. I have been stressing on this. That means 3 plus 2 plus 1 and 1, 2, 3, which is equivalent, and this the derivation that I have drawn is 0. 3, 2, 5 and 1, 6, 3, 2, 5 and 1, 6, which is 0. Now the deviation square. The deviation square is forgetting about the plus or the minus and multiplying it. So 3 into 3 is 9, 2 into 2 is 4, 1 into 1 is 1, 0 is 0, 1 into 1 is 1, 2 into 2 is 4, 3 into 3 is 9. When I divide, or rather when I add to all these, this will give me 9 plus 4 plus 1 plus 0 plus 1 plus 4 plus 9, that is sigma x square will be 28. Now the next that we have is y. In the y, the number of observations are 4, 7, 8, 9, 10, 14 and 18, which means when I add 4 plus 7 plus 8 plus 9 plus 10 plus 14 plus 18, the sigma x is 70 and the number of observation is 1, 2, 3, 4, 5, 6 and 7. So when I divide 70 by 7, it is giving me the y that we have is 10. Now again I draw the deviation. When I draw the deviation, I got this as 10. So 4 minus 10 will give me minus 6, 7 minus 10 will give me minus 3, 8 minus 10 will give me minus 2, 9 minus 10 is minus 1, 10 minus 10 is 0, 14 minus 10 is 4 and 18 minus 10 is 8. Once again 6, 3 and 2, this is 11 and 4, 8, 12, 13. So when this comes, it is 6, 9, 11 and 1, 12. This is the minus that I have, and 4 plus 8 is the positive. This is the negative and this is the positive, which is again same. So my xy or the sigma y will be 0. The sigma y or sigma x has always to be 0 to see that our sum is correct. When I draw the deviation, I forget the positive and the negative signs. 6 into 6 is 36, 3 into 3 is 9, 2 into 2 is 4, 1 into 1 is 1, 0 is 0, 4 into 4 is 16 and 8 into 8 is 64. Now to get my sigma y square, 36 plus 9 plus 4 plus 1 plus 0 plus 16 plus 64 is going to give me 130. Now I draw the multiple deviation. The multiple deviation is when I multiply both the deviation, that is the x deviation and the y deviation. So this is 3 into 6 is 18, 2 into 3 is 6 and likewise. I am going to deviate, or I am going to multiply the x deviation with the y deviation. This gives me this figure. Now I have to find out the sigma xy, which will be 18 plus 6 plus 2 plus 0 plus 0 plus 8 plus 24, giving me sigma xy 58. Now I have everything in hand, and the formula that I have to apply to find out the Karl-Pearson's coefficient correlation is that the correlation is equal to sigma xy upon sigma x square into sigma y square. Now sigma xy, where is my sigma xy? Sigma xy is this last figure that I have drawn by multiplying both the deviation of x and y, which is 58. Then I have to get sigma x square. Sigma x square is 28, so I write 28, and my sigma y square is 130 multiplied by 130. So, this is 58 upon 28 into 130 giving me 0.96 as the answer. So, in this Carl Pearson's coefficient correlation, you must try and understand that we take these two as different identities x and y. We write down their number of observation, we first of all take out the deviation, then the deviation square. Likewise goes for the y observation, and in the end we find out the multiple deviation, which is the deviation x multiplied by deviation y. And the formula which you have to remember for finding out the Carl Pearson's coefficient correlation is that it is sigma xy upon sigma x square into sigma y square. Let me talk about the third method, which is the Spearman's rank correlation. The Spearman's correlation is written as rank correlation this manner. Now, I will be talking about two different set of variables, that is x and y, and which I have written as rank 1 in the x 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, which means the number of observations that I have is 10, and the rank 2 as y, which is 10, 6, 5, 4, 7, 9, 8, 2, 1 and 3. Well, in this method, I will have to first of all take out the deviation, and the deviation according to Spearman's rank correlation is taken out by subtracting R1 and R2. That is, R2 is subtracted by R1. So, 1 minus 10 will give me minus 9, 2 minus 6 minus 4, 3 minus 5 is minus 2, 4 minus 4 is 0, 5 minus 7 is minus 2, 6 minus 9 is minus 3, and 7 minus 8 is minus 1, 8 minus 2 is 6, 9 minus 1 is 8, and 10 minus 3 is 7. After I take out the deviation by subtracting R2 from R1, that is rank 2 from rank 1, I will take out the deviation square. Whenever deviation square is taken out in any method, we always forget the positive and the negative signs. So, 9 into 9 is 81, 4 into 4 is 16, 2 into 2 is 4, 0 into 0 is 0, 2 into 2 is 4, 3 into 3 is 9, 1 into 1 is 1, 6 into 6 is 36, 8 into 8 is 64, 7 into 7 is 49. Now, I will have to take out the sigma d square, which means 81 plus 16 plus 4 plus 0 plus 4 plus 9 plus 1 plus 36 plus 64 plus 49 is 264. So, what I have is the number of observation, and I have the sigma d square, which is 264. The formula of Spearman's rank correlation is 1 minus 6 into sigma d square upon number of observation 3 minus n1, which means 1 minus 6, and my sigma d square is 264 into 264 upon n3, the number of observation 3, that is 10 by the power of 3 minus n1, that is 10. When I do the calculation of this figure, I get 0.6 as my answer. Remember, this is very easy method of the Spearman's rank correlation, wherein we have two ranks R1 and R2 as X and Y. I first of all take out the deviation by subtracting the R2 from R1, and I take out the deviation by multiplying it 9 into 9, 4 into 4, 2 into 2, and I take out the sigma d square, and remember the formula of Spearman's rank correlation, which is 1 minus 6 into sigma d square upon N3 minus N1. When I talk about the merits of the Spearman's rank correlation coefficient, the biggest merit is that it is an easier method than the other methods. Besides, it is also a superior method of finding out the correlation. But its demerits are that it cannot be used when it is in group frequency, the number of observations. Besides, it can be used only in a limited frequency, that is, the number of distribution or the number of observations should not exceed more than 20. If it exceeds 20, then we cannot use the Spearman's rank correlation coefficient. Well, if we have to find out the importance of correlation, the correlation has very positive effects. For example, for the formulation of the policies, we must know the correlation between the variables. For example, if the government lowers the tax limit, then the tax collected will be higher compared to the fact when the tax slab is high. Then the laws and concepts which have to be made, this can be easily made by finding out the correlation between variables. If the laws are stringent, is it that the policies are going to be such that they are going to help the people or they are going to have an adverse effect on them? So, to make the laws and to understand the concepts, it is very important to understand the correlation between the variables. The effects and the relationship between the variables is equally important because one variable will affect the other variable in many ways. So, the effects have to be studied before formulating any policies, concept, laws, effects and relationship. Besides, when a businessman has to take up business decisions, he has to understand the correlation. For example, if he looks at the index of the stock market or if he looks at the currency rate change, he has to understand whether his decision of making business with a particular country is favorable at that time or not. Because these variables, these factors are going to affect, either promote or hamper his business activities. Thus, understanding the correlation by the three methods that which we have seen are very important as far as economics is concerned, because the policies, laws, concepts, effects, relationship, decisions of the businessmen all depend on the relationship between different variables. And that was all about your chapter. Thank you.